So guys, today we'll discuss about OPC poisoning. This is the central nervous system, right? And this is represents the preganglionic neuron, and preganglionic neuron synapse with the postganglionic neuron, and this yellow box represents the ganglion. This neuron before the ganglion is called preganglionic neuron, and it is logical that the neurons after the ganglion is called postganglionic neuron. And the postganglionic neuron in the parasympathetic nervous system, as a neurotransmitter, the postganglionic neuron release acetylcholine, right? You can see acetylcholine is released by the postganglionic neuron, and this acetylcholine stimulates muscarinic receptor on the target tissue. This red box represents the target tissue, and on the surface cell membrane of target tissue you can see there is muscarinic receptor, and acetylcholine stimulates muscarinic receptor on the target tissue. Normally the action of this acetylcholine is very short. Why? Because this acetylcholine is rapidly metabolized by an enzyme called acetylcholine esterase. This acetylcholine esterase metabolized acetylcholine into choline and acetate, right? When acetylcholine esterase enzyme metabolized acetylcholine into choline and acetate, this acetylcholine enzyme metabolized acetylcholine into choline and acetate. Action of acetylcholine is terminated. The action of the acetylcholine is terminated. What does organophosphorus compound do? Organophosphorus compound inhibits this acetylcholine esterase enzyme by forming covalent bond. When organophosphorus compounds inhibits this acetylcholine enzyme by formation of covalent bond, this acetylcholine esterase enzyme cannot break down acetylcholine in this synapse. In this postganglionic synapse, acetylcholine esterase enzyme cannot break down acetylcholine. So acetylcholine in the postganglionic synapse goes very high. So we can tell that acetylcholine effect in the postganglionic synapse will also be high, because acetylcholine cannot be metabolized. So acetylcholine concentration in this postganglionic synapse goes high. So effect of acetylcholine in the postganglionic synapse will also be high. So we can tell that OPC equal to increased acetylcholine effect in the postganglionic synapse or increased acetylcholine effect in the human body. Now see what is the effect of OPC in the gastrointestinal tract. This is the central nervous system. This is the preganglionic neuron. You can see this is the preganglionic neuron, and this is the postganglionic neuron. And postganglionic neuron release acetylcholine, and this acetylcholine stimulates muscarinic receptor of the GI tract. GI tract, you know, there is four or five layers in the GI tract. One is muscularis propria or muscle layer, and the muscle cells of the GI tracts contains M3 or muscarinic receptor, and this acetylcholine stimulates smooth muscles of the GIT. When acetylcholine stimulates muscarinic receptor on the smooth muscles of GIT, right, there is peristalsis of the GIT occurs. Peristalsis. So acetylcholine causes peristalsis of the GIT. This acetylcholine action is terminated by acetylcholine esterase enzyme. But when the person is exposed to organophosphorus compound in very high concentration, this acetylcholine esterase enzyme is inhibited. When acetylcholine esterase enzyme is inhibited, acetylcholine cannot be metabolized in the GIT. So in the GIT, acetylcholine concentration goes sky high. And this sky high acetylcholine concentration leads to excessive stimulation of the peristalsis of the GIT. That means of the stomach, of the small intestine and large intestine. So when there is peristalsis is stimulated, it can cause diarrhea or hyperdefecation. It can cause vomiting, and increased peristalsis can lead to abdominal cramp. So this is the effect of OPC in the gastrointestinal tract, right? Now we can see the effect of OPC in the urinary system. This is the central nervous system. This is the preganglionic neuron. This is the postganglionic neuron. Again, postganglionic neuron releases acetylcholine, and this acetylcholine stimulates muscarinic receptor on the urinary bladder. If I want to say very precisely, on the wall of the urinary bladder, you know there is detrusor muscle. This is detrusor muscle, and on the surface of detrusor muscle there is muscarinic or M3 receptor. Acetylcholine stimulates this M3 receptor on the detrusor muscle. When acetylcholine stimulates this M3 receptor on the detrusor muscle undergo contraction, and so we can tell that urinary bladder undergo contraction. And when urinary bladder undergo contraction, urination will occur, right? Urination will occur. So acetylcholine in the urinary bladder leads to stimulation of M3 receptor in the detrusor muscle and leads to urinary contraction or contraction of the urinary bladder and ultimately lead to urination. So what does happen if a person is exposed to OPC? If a person is exposed to OPC, this acetylcholine esterase enzyme in the urinary bladder is inhibited. So what happened? This acetylcholine esterase enzyme in the urinary bladder is inhibited. So acetylcholine cannot be metabolized in the urinary bladder. So acetylcholine concentration in the urinary bladder goes high. And when acetylcholine concentration in the urinary bladder goes high, this acetylcholine leads to excessive stimulation of the detrusor muscle, and excessive stimulation of the detrusor muscle leads to involuntary urination, right? So OPC poisoning leads to involuntary urination. Now we'll see the effect of OPC in the sweat gland. This is the central nervous system and preganglionic neuron, and this is the postganglionic neuron. Remember, this is a sympathetic pathway, this is not a parasympathetic pathway. And postganglionic neuron release acetylcholine, and acetylcholine stimulates muscarinic receptor on the sweat gland, and this leads to sweating. But again, you need sweating when you sweat when you need sweating, and inappropriate sweating is inhibited by metabolism of acetylcholine by this acetylcholine esterase enzyme. So what does OPC do? If a person is exposed to OPC, acetylcholine esterase enzyme is inhibited. So acetylcholine in the sweat gland cannot be metabolized. So inappropriately acetylcholine concentration goes high, and this increased concentration of acetylcholine in the sweat gland leads to profuse inappropriate sweating. So there is profuse inappropriate sweating because acetylcholine in the sweat gland cannot be metabolized. Now coming to the function of acetylcholine in the lacrimal gland and salivary gland. This is the central nervous system, and again preganglionic neuron. Again you can see postganglionic neuron. Postganglionic neuron release acetylcholine, nothing new. And this acetylcholine will stimulate M3 muscarinic receptor on the lacrimal gland and salivary gland. And when acetylcholine stimulates muscarinic receptor on the lacrimal gland and cerebral gland, lacrimation and salivation will occur. But in the presence of OPC, acetylcholine in the lacrimal gland and salivary gland cannot be metabolized because acetylcholine esterase enzyme is inhibited. So acetylcholine in the sweat gland and salivary gland goes very high. So when acetylcholine in the sweat gland and salivary gland goes very high in OPC poisoning, there is excessive salivation and there is excessive lacrimation. Also, you should remember there is tracheobronchial gland and there is pharyngeal gland and there is laryngeal gland. Everywhere acetylcholine concentration goes high. So tracheobronchial glandular secretion will increase. Pharyngeal gland secretion will increase. Salivary glandular secretion will increase, and all this increased secretion leads to frothing from the mouth, right? All this increased secretion leads to frothing from the mouth. Now coming to the effect of acetylcholine into the heart, and this is central nervous system, and this is preganglionic neuron, and this is postganglionic neuron. Postganglionic neuron release acetylcholine, and acetylcholine, this is heart, and this two green dots represents SA node and AV node. This is SA node and this is AV node. SA node and AV node contain M2 muscarinic receptor. Acetylcholine stimulates this M2 muscarinic receptor and inhibits the SA node and AV node. When acetylcholine inhibits the SA node and AV node, there is bradycardia, heart rate goes down. So the function of acetylcholine in the heart is to cause bradycardia, right? Decrease in heart rate. But when person is exposed to OPC, acetylcholine esterase enzyme is inhibited in the heart. So acetylcholine in these synapse, postganglionic synapse, cannot be metabolized. So there is increased acetylcholine concentration in the postganglionic synapse of the heart, and this increased acetylcholine in the heart leads to excessive stimulation of SA node and AV node. When there is excessive acetylcholine leads to excessive stimulation of SA node and AV node. SA node and AV node basically excessively inhibited. because acetylcholine causes inhibition of the SA node and AV node. So acetylcholine leads to excessive inhibition of the SA node and AV node, right? When acetylcholine leads to excess inhibition of the SA node and AV node, there is bradycardia, or heart rate goes down. And when your heart rate goes down, your cardiac output goes down, because cardiac output equal to heart rate into stroke volume. And when your cardiac output goes down, your blood pressure goes down, because blood pressure equal to cardiac output into total peripheral resistance. So ultimately OPC poisoning leads to hypotension. So it is logical that you will monitor the blood pressure in emergency ward in a patient of OPC poisoning, and you will also monitor the heart rate, right? And now coming to the bronchus. This central nervous system, this is preganglionic and postganglionic neuron. Postganglionic neuron release acetylcholine, and this acetylcholine stimulates M3 receptor on the smooth muscle of the bronchus. This M3 receptor is present in the bronchial smooth muscle and bronchial glands. When acetylcholine stimulates this M3 receptor, there is bronchial smooth muscle contracts. So there is bronchoconstriction, right? So the first function of acetylcholine in the respiratory tract is bronchoconstriction. Second, glands, there is glands in the bronchus and trachea, and these glands contain M3 receptor, and acetylcholine stimulates this M3 receptor and causes increased glandular secretion from the bronchus, right? Increased glandular secretion from the bronchus and trachea. So there will be increased tracheobronchial secretion. So but when the person is exposed to OPC, acetylcholinesterase enzyme in the bronchus is inhibited. So acetylcholinesterase enzyme cannot metabolize this acetylcholine. So there is excess acetylcholine will accumulate in the bronchus and bronchioles, and this excess acetylcholine in the bronchus and bronchioles leads to excessive bronchoconstriction and excessive glandular secretion, because this excess acetylcholine will now lead to excessive stimulation of this M3 receptor in the bronchial smooth muscle and bronchial glands, and leads to excessive bronchoconstriction and glandular secretion. When there is excessive bronchoconstriction, bronchial diameter goes down, and when there is excessive glandular secretion, this glandular secretion will accumulate in the lumen of the bronchus. When there is increased glandular secretion will accumulate in the lumen of the bronchus, and there is excessive bronchoconstriction, there is decrease in diameter of the bronchus, and when there is decrease in diameter of the bronchus or bronchioles, bronchus and bronchioles gets narrow, and you can hear bronchi, and this narrowing of the bronchus and bronchioles leads to respiratory distress. So it is logical that we will monitor the lungs of the patient in emergency situation in OPC poisoning, right? So we can get shortness of breath and you can get bronchi. Now coming to the function of the skeletal muscle, you can see this is the spinal cord. From the spinal cord there is motor neuron, and from the motor neuron signal goes to the skeletal muscle, right, and leads to skeletal muscle contraction. And what happens, this is the cell body of the motor neuron, and an action potential travels through the axon, and action potential now travels through the axon and reaches the neuromuscular junction. This is the neuromuscular junction, and junction between the motor neuron and the muscle, and this action potential lead to muscle contraction. This is the nerve terminal or neuromuscular junction, and when action potential comes, calcium enters into the nerve terminal, right? Calcium enters into the nerve terminal, and this entered calcium into the nerve terminal leads to release of vesicle containing neurotransmitter. This is the vesicle, and inside this vesicle there is acetylcholine, and you can see there is some green channels in the neuromuscular junction. This is the muscle membrane or motor end plate, and this muscle membrane contains some channels. This green channel is sodium channel, and when acetylcholine is released, the sodium channel is first stimulated, and when the sodium channel is first stimulated, this green channel, there is muscle contraction occurs. Though I go to very short, but it is very details, and it is not my today's discussion, part of my today's discussion. So when the sodium channel is opened and if it is stimulated enough, and this leads to action potential, and this ultimately leads to muscle contraction. But what happened in OPC poisoning, we can see. So this is the spinal cord, this is motor neuron, and this motor neuron will innervate a skeletal muscle, right? And this skeletal muscle contain nicotinic receptor, and motor neuron release acetylcholine. There is no such pre and post ganglionic neuron in this case. There is only one motor neuron, and this motor neuron release acetylcholine, and acetylcholine will stimulate nicotinic receptor, and nicotinic receptor stimulation lead to skeletal muscle contraction, right? In OPC poisoning, acetylcholine cannot be metabolized, so there excess acetylcholine will accumulate in the synapse, and this excess acetylcholine first leads to stimulation of that NM receptor, and stimulation of this NM receptor leads to first fasciculation and twitching and slight contraction of the muscle. But when there is prolonged stimulation of this NM receptor by this increased concentration of acetylcholine, when this excess acetylcholine leads to prolonged stimulation of this NM receptor become desensitized, or in the animation you see the green receptor is desensitized. So when this NM receptor is desensitized, what happened? Actually this NM receptor is one type of sodium channel. This is acts both as receptor for acetylcholine, this also acts as sodium channel. So when the sodium channel or NM receptor or sodium channel is desensitized, how much acetylcholine in the synapse, it doesn't matter, the muscle doesn't stimulate further. The muscle become paralyzed, because when this receptor is desensitized, this receptor doesn't work, and when this receptor doesn't work, you cannot produce an action potential in the muscle, so you cannot produce a muscle contraction. So first there is excess acetylcholine, and this excess acetylcholine leads to stimulation of NM receptor, and stimulation of NM receptor leads to muscle contraction, twitching, fasciculation. But later when this, due to prolonged stimulation, this NM receptor become desensitized, muscle cannot contract because action potential in the muscle cannot be produced. So there is weakness and paralysis of the muscle in long run. So first there is fasciculation and twitching. Ultimately, due to desensitization of sodium channel or NM receptor, there is weakness and paralysis, and this can lead to respiratory failure and death in OPC poisoning. That is why OPC is very dangerous. And this function of OPC, you cannot reverse it by atropine. You have to give pralidoxime. So if examiner asks you in the exam why we give pralidoxime, we give pralidoxime to reverse the muscle paralysis. All other function you can blocked by atropine, but this function cannot be reversed by atropine, because this is a nicotinic receptor. Atropine cannot block this nicotinic receptor. Atropine only can block muscarinic receptor. So to reverse the function, you have to regenerate acetylcholine esterase, and to regenerate acetylcholine esterase, you have to give pralidoxime. In the OPC, what is the function of OPC in the central nervous system? In the central nervous system, OPC inhibits acetylcholine esterase and leads to excess acetylcholine concentration in the central nervous system, and this leads to headache, confusion, convulsion, coma, and ultimately death. And to control the convulsion, you have to put IV diazepam to control that convulsion. So this is basically the discussion of it.